This video is in response to a question about a homework problem in section 10.2, which is on the topic of hypothesis tests for a population proportion. And I'm going to walk through how to solve this problem. This is question number 11. So this problem states, for every football game, there is a team that is expected to win by a certain number of points. This is called the spread. If the point spreads are accurate, we would expect about half of all the games played to result in the favored team winning, and about half for the favored team to not beat the spread. So we're provided a data set with 45 randomly selected games. So zeros indicate the favored team did not beat the spread, and 1 indicated that they did. So we're trying to figure out if the data suggests that sports books establish accurate spreads. So if we take a look at this data set, it's a bunch of zeros and ones. So every 1 is considered a success, and every 0 is considered a failure. So this is a population proportion because we have sort of a yes-no scenario. And so we're going to do a hypothesis test. You can see the student answered parts of this already. So first we have to determine if we can use a normal distribution for this. So in order to do that, we have to make sure that n times p naught times 1 minus p naught, this is greater than 10, which it is. So n, again, is the number of selected games, which is 45. P naught is sort of our baseline comparison that we're doing of what we expect. And we expect about 50-50, so P naught is 0.5. So it's 45 times 0.5 times 0.5, and that's 11.3, which is greater than 10. And then the sample size needs to be less than 5% of the population size. We're not really told how many games there are, but this is every football game, so we would assume that there's a large number of those, and that 45 games would be less than 5% of all of the games. And so we're also told that we have randomly selected games, so we have to have the sample be random, which it is because it was given that it was random. So the requirements for doing this test are satisfied. Now the next part is the null hypothesis. Again, that's what we expect, and so we want to know if our population proportion is equal to 0.5, or the null hypothesis is that it would be equal to 0.5, and then the alternate hypothesis is that it's not equal to 0.5. So that's what we're trying to figure out, whether or not we can reject the null hypothesis. So to do this, we use StatCrunch. So I'm going to click on the little icon and open StatCrunch. So here's StatCrunch, and to do this, we're going to do a hypothesis test on a proportion statistic. So we do proportion statistics. It's just one sample of 45, and we have data here instead of summary. So we say with data. All right, so the values of our data is in 1. It is in var 1 column. Now success is what can StatCrunch assume is considered a success in this data set. And so, as I said, successes are 1s and failures are 0s. So we type a 1 in there. And then we're doing a hypothesis test, and this is actually already set up for us correctly, so we don't need to change it. And I want to show the critical value here. And I think, does it say what the significance is? Well, we'll just have to leave it like that for now and then get to that portion of the problem. So let's hit compute. All right, so we have 20 successes and 45 total. So 20 is our x and 45 is our n. So our sample proportion, our p hat, is just x divided by n, which it calculated for us, and that's 0.444. So we'll put that in there. And then the next part says find the test statistic z0. So that's also in our output, and that is this z-stat. So z-stat is the z0 that's asked for in these problems, And again, round to 2 decimal places as needed. So that's negative 0.75. And then we're asked to find the p-value, which is also in the output. So the p-value here is 0.3 decimal places, 0.456. Now the final question is whether or not this data suggests that the sport books establish accurate spreads. So what we're trying to figure out is whether or not we can reject the null hypothesis. So the p-value in these types of problems is the probability of observing a sample statistic that is at least as extreme as the one we gathered. So our sample statistic is this 0.44, and that's not really that extreme. That's not that far from 0.5, and we have a really high probability that we would observe a sample that is extreme as that. So since the probability is so high, we do not reject the null hypothesis, because in order to reject the null hypothesis, the p-value has to be less than or equal to the level of significance. Now, as I said when we did the test, no level of significance was provided, but so it's normally 0.5, 0.1, something that's a very small probability of occurring. And so this says we have a high likelihood that it's occurring, so we do not reject the null hypothesis. So it's one of these two. So although no level of significance is given, the data suggest the spreads are accurate, meaning we're not going to reject it. And we agree with this expectation that the sports books establish accurate spreads. There you go. I hope this helps.